People are smiling, that means yes.
Other side. We are men. We are men.
You guys
No,
don't have
big deal. No.
you guys don't have any.
We don't have a big deal.
Okay, so everybody is familiar. Nice. So Dr. Broca is the one who actually highlighted the different parts which I mentioned. Okay, that's considered as a part of the limbic system. But interestingly, he didn't consider these parts as the emotional behavior were involved in it. He was just saying that it's actually the olfactory, which is actually the function. Then there was another guy that came in, and he actually says that the behavioral and emotional role of the limbic system. How many of you know it? The Pappas circuit? Okay, so I'm not going to talk about it a lot. Can anybody explain him?
The what?
You guys have, okay, by looking at the picture, can anybody do it?
We just know that the anterior part of the thalamus is involved.
No, we don't
Okay.
know.
I'll just quickly wrap it up because Pappas circuit is the one which is actually going to give you it gives a little platform of how the things are worked here. Now, if you look at the circuit here, it starts from the cingulate gyrus and then goes back to the cingulate varus. So whatever the information that you receive from your sensory cortex, okay, your association sensory cortex or whatever you have, it's going to go into the cingulate gyrus. That's the cingulate gyrus. It's like, again, you're responding in response to your stimulus and your environment. It's not just sensing it. For example, if I'm looking at a certain person, I'm looking at it, right? But if I know him from the past, it will be like in connection to this hippocampus and all that because I have some memory from the back, long-term memory, and then I can respond accordingly. Okay? So this is something sometimes like you can say that you can modify a bit, and I think you have done it in detail when you took a lecture for physiology. Now the cingulate gyrus here is actually connected to the hippocampal formation. Everybody can picture that through the cingulum. Cingulum is nothing; it's just the fibers which are running in the cingulate. So cingulum is connecting the cingulate gyrus to the hippocampal formation. Yes?
Dr. Amna is the fornix.
No, fornix is this one.
Yeah, but they're also connected at the same time.
I will just fine. I'll finish this up. There's actually a diagram showing you the input and output. That explains the whole thing again. Okay, guys, quickly. Cingulate gyrus gives the fibers through the cingulum. Okay, they're called cingulum, and then they will be reaching to the hippocampal formation. And then the hippocampal formation will connect to the mammillary body through the fornix. Now you guys can picture the fornix in your mind. It's looping around over the corpus callosum. Then from the mammillary body, it's going to go to the anterior thalamic nuclei, which is also considered as part of the limbic system. That is the mammillothalamic tract. And then back to the cingulate gyrus. Okay? So this is what he said, that this is how they are connected. It still exists. It's just that another guy named Dr. Paul McLean, he added the amygdala. Okay? And then he actually also added the prefrontal cortex or the association cortex, so that they are all connected. Is that clear? So now it makes sense more because now the amygdala is... Yes? You have a question?
So what's the function of this?
Sorry?
The function of the circuit.
The function of the circuit.
Exactly, because just give me maybe a minute or two and I'll explain it to you. But the function is just that, this is just the pure structure-wise the connection. But definitely what you're doing, as I said, when you're receiving a sensory input in your cortex, you have to, it doesn't matter, sometimes you have to respond accordingly. For example, if you sense a danger, then you have to work accordingly. Amygdala might be needed because of your emotions and your fear so that you can alert yourself, right? If you don't have amygdala, for example, you will not be able to alert yourself and you will not be able to behave accordingly. Is that clear?
Yes.
And then hippocampus will also help you out in your, if you have experienced a similar thing like this, so it's going to help you out to improve your respond accordingly. Is that clear? So this is how it's actually kind of working. Yes? Yeah, no, association cortex, that doesn't mean only the prefrontal cortex. Association cortex can be anything. It could be parietal, temporal, occipital cortex. There are many association areas. Okay? Whenever it says association, it means something more advanced and more modified that you're doing. Remember the sensory association cortex, you have motor association cortex, so they are actually kind of modified whatever you just received it initially. like a more, how can you say it? More skilled or more, I'll come back to that. Okay. Now, amygdala, why is it not? When they added the amygdala into the circuit, there was another group of scientists. They actually proved that why amygdala or other parts of the limbic lobe or the temporal lobe, which mainly contains the hippocampus and the amygdala, are removed, then what will happen? Okay? So they kind of did the bilateral temporal lobectomy, and then they presented that the monkey with the Kluver-Bucy syndrome. I'm sure, have you heard that or no? No? Okay, guys, Kluver-Bucy syndrome is something that they actually did was the bitemporal lobectomy. They removed the temporal lobes of both the sides of the monkeys, and they observed the behavior, right? And we just talked about it, that all the important structures of the limbic system, they are present in the temporal lobe, hippocampus and amygdala mainly. Okay, so what was the presentation of those? They actually kind of shows the docility and loss of memory, and that will be due to the amygdala. Somebody mentioned it just now. Docility means that monkey were able to tame, able to control. They don't have any acid responses because they're not anxious. Because when you remove the amygdala, what will happen?
No fear, no
emotions. Basically, it's something to do with your anxiety, your rage. If you overstimulate amygdala, patient will respond with overaggression. Okay, this has also been observed. This has also been observed. So if you remove it, so this kind of the person or the animal in this one, the behavior will be like more docile, more like kind of calm, and it will be easy to control. What is that? Then you have the visual agnosia. Visual agnosia, I'm sure everybody's familiar with that term. What is it?
We can't recognize it.
Yes. If I see somebody in front of me, and if I know him, I will not be able to identify it, or something, not the person, even the thing. So it's not about the vision, it's about the understanding or the perception or the stimulus. Okay? Then you have hypermetamorphosis. This is the unusual behavior they observed, that the monkeys, they were actually taking a lot of things, or trying to explore everything by taking it orally. This is the behavior they observed, okay? Then, apart from that, there was a altered sex behavior. They explain it due to the olfactory area involved, because it's also connected to the amygdala. Then, obviously, they're not able to learn new tricks because there's no hippocampus and there will be no consolidation from short term to long term. They might remember it for a while, but they will forget. This is something happens in amnesia. Okay, if you have a hippocampus involved or affected, patient will have the long-term memory, but he will not be able to retain the short-term memory. For example, if I hear your name, I might remember it for a minute or two, but I'll be forgetting it after that. But I will remember whatever has been fed into my brain as a long-term memory. Like this is something happens with the older people that always go back to the flashback memory, like they go back into past times. They don't remember the things in front of you. Like, for example, I have a grandmother. She has the same thing. Every time I go and visit her, I have to explain that who am I, because her time actually stops when she was young and my mother was young as well. Like they were kids. So she always asks, okay. So and then she started talking about as if she were in those days. Okay, so there were no short-term, there was only long-term memories that were lasting.
Doctor, what's the relationship between the olfactory area and the sexual behavior?
Because of the aura and the hypersexualism. This is what they explain. Sorry? Somebody was saying something?
Can you briefly explain what's hypermetamorphosis?
Hypermetamorphosis, this is the unusual behavior they observed while they took the temporal lobe out. What is hypermetamorphosis? That the monkeys, they were taking everything orally, as if they want to explore everything by taking it into their mouth. This is like the unusual behavior they expect. This is the presentation you usually have if you have an involvement or one of the parts of the temporal lobe.
Is this in children as well?
Sorry, yes, it can happen.
I mean, don't they do this normally?
Oh, you mean like
Early on.
early on? So it can, yes, it can be the explanation because there's still development process is on, so they don't know. It could be due to that, but I'm not exactly sure.
Does your grandmother remember past events more clearly?
Yes, she
Why is that? Like they remember long-term events much more clearly?
I'm not exactly sure, but I think that's what I believe is because now you don't have more new memories to retain. So the one which are, this is what my understanding. So this is something that like maybe the one she has is the previous or the past one. They kind of, now she's only in those memories, so they become more stronger and stronger. Because they don't know new memories or the short-term memories. Yes.
What is the psychiatry that the amygdala has been
Don't talk to psychiatry. Okay.
but it will lead to hyposexuality. So how can you say
Hypo.
yeah. The amygdala has
Maybe I could.
It will cause dysfunction, yeah.
I don't remember. This is what I remember, but I'll. Okay, so basic game plan. Now remember, this is just to give you an idea or whatever we just talked about. When you see something in front of you, okay, like let's say if you sense a danger, how do you respond? I'm not talking about that how the brain works. You run, okay? Let's say if you sense there's a fire or somebody like your friends just started screaming and saying, oh, there's a fire. What will you do? You run without even thinking, okay? So otherwise, if you have taken after some time, then you start thinking, I was like, okay, I should have checked, or I should have informed the others, or if it was actually the fire was not there or not. So these are the two things that actually simultaneously is going to happen. One take a little longer time, the one which is actually the immediate response. Okay? So for example, if you start panicking, you start screaming, or you start running, this is something that is directly in connection or in relation to your amygdala. Okay? So that's how you're responding. But some of the fibers or some of the connections, they're actually going to relay into the cortex. They're going to kind of make it, what do you say? More logical, more sensor, or more like cognitive kind of, or more calculated kind of a way, but it requires some time. So everything will go and then comes to singulate and then singulate to the amygdala and the hippocampus. But you will be more in your senses, right? Sometimes you actually say it, right? So I'll be in my senses maybe in a minute or two. This is how it works. So usually, and then at the same time when this is happening, the cortex also kind of controlling the amygdala as well. So you doesn't overreact or you don't over panic. So it's kind of like a balance. For example, if you sense a danger, the brain is preparing for you for the worst outcome. Okay? But if you're just going to have one pathway, you're going to take a time. So it's kind of preparing for both the things. You don't overreact, you just don't do anything at all, you take time for it. Okay? So this is what exactly happening. So once you see any sense of danger, where is it going? You're looking at it, so definitely it's going to go into the occipital lobe. And then if it's going into the association cortex, it could be anything like, for example, first it will go to parietal temporal occipital, and you will sense that what is the danger, where is it, okay? And then it will also reaches ultimately to the prefrontal cortex or the pre-orbital cortex. I'm sure everybody knows what prefrontal or pre-orbital functions is. What does it do? Exactly, so it's more advanced, more skilled programming of your brain, right? So again, you're calculating it. So once you do that, then it's going to send the information. Remember the Papillary circuit along with the one with the amygdala and the prefrontal. It is going to send the information to the limbic lobe or the different parts of the limbic system. Then the fibers are going to go inside the hippocampus and the amygdala. And from there, you will go to the cortex again to respond accordingly. So basically, the amygdala is kind of organizing the response, right? And whatever the potential threat you have, and so that you actually kind of emotionally react to it. And then the hippocampus is kind of learning or recalling from whatever you have experienced previously. So they work together. Is that clear? Now, these are the different inputs and outputs. I'm not going to go into a lot of details. Just quickly, I'll show you the hippocampus one, and then we're done. So as I talked about, that this is actually, somebody was asking you what is cingulin. So this is the cingulin here. These are the purple fibers that are running within the cingulate gyrus. They are receiving the input from all the association cortical areas, and ultimately they will be ending up into this area here, which is highlighted with purple. This is called entorhinal cortex. Any idea what that is? Okay, so it's actually next to the, or the parahippocampal gyrus. It contains the entorhinal cortex. Yes, it's associated with the olfaction or the olfactory center. Apart from that, it also actually kind of checks everything that goes to the hippocampus. So if you look at the arrows now, once it's received, then everything is, some of them will go directly to the hippocampus, some of them are actually going through the entorhinal cortex here. Can you see this? The arrows. So these are all the inputs. Then what else? Amygdala, of course, because it's connected. So you're getting it from the entorhinal cortex, just to make sure it's like is it like the things that we required, or the stimulus, is it supposed to be processed into the limbic system or not? And then you have the amygdala. Then you have the outputs. Outputs is now, you've already done it. This is just a revision kind of a thing. What is this? So if you start from the outputs, the major output, that is the fornix, which is coming from the hippocampus, going into the medullary body, right? And then from here, it will go into the anterior nucleus of the thalamus, that is the mammalothalamic tract. Who was asking? Somebody was asking earlier regarding the fornix. So this is the corpus callosum. So see how it is connected to it. And then you have the mammalothalamic tract, and from here into the cingulate gyrus back. Okay, so you have the diverse cortical association areas, and also to the entorhinal cortex to modify, and to also, this is something that it's okay, like, and then they're actually trying to show you, then once it's received, the cortex is again coming back to the hippocampus formation. Okay, is that clear? So this is the same thing that we just talked about, the pappus circuit, along with the amygdala and everything. Now, amygdala, so these are the inputs showing, you don't have to go into a lot of details. Have you guys covered this in the physiology or no?
No.
You will do it, right? Or no? Okay, just want to show you this one here. So you can see the amygdala is also connected to the hippocampus, right? And also the part of the brainstem. Can you see this? So as we said, if amygdala is stimulated, definitely you're showing your emotions, and emotions comes up with the different changes in your body. Increased heart rate, and then you have sweating, and different and other stuff that is going on, like the rage and all that. So this is all connected to the brainstem, and same thing goes back as an output as well. Okay? Now don't panic after seeing this, because I'm not going to talk about much, just want to show you this. So this is all connected to different structures of the brainstem, and it is giving the output.
Doctor, is this the HPA axis?
Sorry?
Is this the HPA axis?
ايوه بالضبط HPA axis.
Hippocampus, pituitary, adrenal.
Okay, last thing. Nice. Now, this is again more of like a functional component, but I just want to show you there are different neurotransmitters that are being sent into the limbic system through different tracts from different parts which are present within the brainstem. Okay? And some of them are inhibitory and some of them are excitation. Why they're important? Because if you're going to target these, you're actually going to see control different mood disorders like depression and everything. Okay, like for example, I'll give you example of serotonin. They call it as a happy drug or happy hormone. So if you have an inhibition up to that, it kind of leads to the depression, and there could be any other reasons as well. But this is one of the explanations. So this is something that you should be seeing it. This is how they're connected. Okay, thank you so much. Any questions?